In this lecture, we're going to study bonding and orbitals. Now, and we're going to relate chemical bonding to how orbitals basically behave when a chemical bond is being formed. Now, in O levels, you were familiar with dot and cross diagrams, and we're going to start off with the simplest covalent bond. We're going to study covalent bonds right now. We're going to discuss ionic bonds a little later in the next few videos, but we're going to start off with covalent bonds. Now, if you remember your stuff in O levels, let's start off with the easiest. Hydrogen had one electron, and in H2 molecule, there were two hydrogen atoms bonding to each other. So each of the two hydrogen atoms had one electron, and then ended up forming. This was called H2. And let's draw the dot and cross diagram for this particular molecule. There was one electron in one of the hydrogens that was being shared by one electron of the other hydrogen atom. So one of that was drawn with a dot and the other one was drawn with a cross. So this was the dot and cross diagram representation of an H2 molecule. So let's write that down, dot and cross diagram. So this is what chemical bonding looked like when you were doing your using your old concepts of electronic configuration. Now using orbitals, we're going to study how this exact bond is going to look like. So let's start off with the electronic configuration of hydrogen first. Hydrogen has one electron, so the electronic configuration of hydrogen is 1s1, and the other atom is also hydrogen, so it has a similar electronic configuration of 1s1, which basically means there's only one spherical s orbital, which has how many electrons? It has only one electron. Now remember one thing when we're talking about covalent bonds. Covalent bonds are only going to be formed by half-filled orbitals. And we're talking about normal covalent bonds. So normal covalent bonds are only going to be formed by half-filled orbitals, and there are a couple of reasons why half-filled orbitals are involved in bonding. The first reason is that they have space to accommodate an electron. And the second reason is also related to the first reason, which is that space exists close to the nucleus. For example, if you look at the hydrogen atom, an electron can be accommodated, an extra electron can be accommodated in the s orbital because there's room for an extra electron. But there are other orbitals as well. There's an empty 2s orbital, there's an empty 2px orbital, a 3s orbital, a 3d orbital in the hydrogen atom, but those orbitals lie very, very far away from the hydrogen nucleus. And since they are very far away, the force of attraction between the nucleus and the electrons which are going to be residing away from the nucleus is not going to be much, so they won't stay there. So the half-filled orbitals are always going to be lying close to the nucleus, so an electron would easily get attracted to the nucleus if it's lying in that orbital. So let's get this clear that only half-filled orbitals are going to be involved in bonding when we're talking about normal covalent bonds. And let's figure out how an H2 molecule would look like. Hydrogen has an electronic configuration of 1s1, which basically means that there's a spherical region, the nucleus is in the center, and there's one electron residing in this spherical region. So there's only one electron residing in the spherical region. So this is one of the hydrogens. Then there's another hydrogen atom, and there's going to be this is another hydrogen atom, and there's going to be one electron residing in this spherical region, and there's only going to be one electron in this spherical region. So now there's room for an extra electron in both regions. What happens is that the positive nucleus over here starts to attract the electron which is roaming around in this spherical region. So if it starts to attract it, it starts to pull the electron cloud towards itself. The same applies to this positive nucleus, starts to attract the electron which is residing in this element, and it starts to attract it towards itself. Eventually, what happens is that the two electrons and the two regions, they start overlapping and they mix. So what you get is uh, you get two nucleuses, and both of them are now attracting the two electrons mutually. So the two electrons are residing in this entire uh, new orbital which is formed. This orbital is called the bonding orbital. So the two orbitals which were separate, which were part of different atoms, have now merged and they have mixed together, and the two electrons are now equally being shared between the two nucleuses. And what happens is that the negative charge density is maximum in the center, and this negative charge density is going to attract the positive nucleus over here. It's also going to attract the positive nucleus over here. In a way, it is going to join the two atoms together, which is going to form a bond. So there's going to be an electrostatic force of attraction present between opposite charges. The negative electrons in the center is going to attract the positive on the right side, and this positive nucleus on the left hand side as well. So a bond is formed, and there are going to be two electrons in that bond, and this is going to be the new region where the two electrons are going to exist, and this is called the bonding orbital. In a similar way, we're going to discuss the bond that is found between hydrogen and fluorine, and we're going to discuss the covalent bond. And remember that in a covalent bond, half-fill orbitals are involved in bonding. The reason is that there's space available in that orbital to share an electron, and also that space is close to the nucleus, so the electron is going to be attracted to the nucleus very strongly. So let's discuss hydrogen again. Hydrogen had one electron, so the electronic configuration of hydrogen was 1s1. Let's take the case of fluorine. It has a total of 9 electrons. So 9 electrons, the electronic configuration is going to be 1s2, 2s2, 2px, 2py, and 2p. Z. So there would be 2 electrons in 2px, 2 electrons in 2py, and 1 electron in 2pz. Now let's try and draw the two atoms. So drawing hydrogen would be very easy. There's going to be a nucleus at the center, a positive nucleus, and there's going to be a spherical region around that nucleus, and this is going to be the 1s orbital, and it's going to have 1 electron in this particular region. So there's only 1 electron roaming around in this half-fill orbital. Similarly, let's draw a fluorine atom. So there are 2 electrons in the 1s orbital. So this is a 1s orbital, and these 2 electrons, the 2 electrons filling the 1s orbital. Then there's a 2s orbital. The 2s orbital is going to be a bigger region. It's going to be spherical as well. So there are 2 electrons in this spherical region, which is called the 2s orbital. So I've drawn the 2s orbital. Now I have the 2px, 2py, and 2pz orbitals. So let's say this over here is my, let's call it the z-axis. This over here is my uh, y-axis, and the x-axis for a change is coming out of the page and going into the page. Now, the 2p x orbital is going to be, I'm going to draw it with a different Now let's draw it with the red marker as well. So the 2px orbital is going to be dumbbell shaped. There would be a region on both sides of the nucleus that's going to have two electrons. The 2py is also going to have two electrons. So this over here is the 2p y orbital, and let's draw the 2pz orbital with a different marker. That's going to be lying on the z-axis, and that's going to be holding just one electron. So this is the orbital. The orbital in blue is the one which is going to be it has the capacity to accommodate an electron. So let's circle this 2pz orbital. This is the one that's going to be involved in bonding. Similarly, from the hydrogen side, it's the 1s1 which is going to be involved in bonding. So the other orbitals are all completely filled. They don't really have space. So in a similar way, if we just focus on the 2pz orbital, and let's circle this with blue as well, because this is the orbital that's going to be involved in bonding from the hydrogen side. So if you look at the two orbitals only, and forget the rest of the orbitals because they are completely full and they cannot accommodate electrons. So the nucleus of the fluorine atom is going to attract the electron from this side, whereas the nucleus of the hydrogen atom is going to try and pull the electron in the half-filled orbital towards itself. So the two atoms are going to try and pull electrons out from each other. So let's redraw this, and let's forget all the other orbitals because they weren't even involved in bonding. So what's going to happen is uh, you're going to have an s orbital with a nucleus in the center. This is the hydrogen atom, and you're going to have a p orbital. This over here is the fluorine atom. This is the 1s1 orbital, and this is the 2p Z half-filled orbital from fluorine side, and this is the central nucleus of the fluorine atom. So there's one electron over here, there's one electron over here. They're both trying to pull this electron over here is going to be attracted to the positive nucleus of the fluorine atom, and this electron in this region is going to be attracted by the positive nucleus of the hydrogen atom. So they're both attracting each other, and they're going to start overlapping, and eventually they're going to start sharing electrons. What's going to happen is that once these two orbitals overlap, this is the shape of the new orbital that's going to be formed, and they're going to be two electrons residing in this bonding orbital. This would be called the bonding orbital that's going to be formed between bonding orbital, and this is the bonding orbital that's going to be formed when fluorine atom tries to bond with a hydrogen atom. The 2pz orbital of the fluorine is going to overlap with the 1s orbital of the hydrogen atom. The negative charge, most of it is going to be uh, present between the two nucleuses, and since it's present between the two nuclei, the negative charge is going to attract the nucleus of the fluorine atom, and it's also going to attract the nucleus of the hydrogen atom, and they're going to stick together. So this is the bond that's going to be formed between hydrogen and fluorine. In this lecture, we're going to discuss the bonding between one fluorine atom and the other fluorine atom. Now, uh, we would first draw the dot and cross diagram of fluorine. Now, you have fluorine. We already know a fluorine molecule, it's in group 7, it's a diatomic molecule. So two fluorine atoms join together and they have a single covalent bond between them. Now, fluorine has a proton number of 9, which basically means it has 9 electrons. So, if I draw the dot and cross diagram of a fluorine atom, it's going to look like this. There's a fluorine in the center. There are two electrons in the inner orbital and inner shell, and there are 7 electrons roaming around in the outer shells. And if you remember properly how covalent bonds were drawn in O levels, then there would be another fluorine It's going to have 2 electrons in its inner shell, and it's going to have 7 electrons in its outer shell. So it would be sharing exactly 2 electrons in the covalent bond. So it's sharing 2 electrons over here. Now, this was the old method of drawing covalent bonds. Now, let's incorporate orbitals and figure out how that bond actually is going to look like with a new knowledge of orbitals. Now, fluorine has 9 electrons. Its electronic configuration is going to be 1s2, 2s2, 2px, 2py, 2pz. I've already put 2 electrons, so there are a total of 4 electrons in the first two orbitals, and we are left with 5. So there would be 2 electrons in 2px, 2 in 2py, and only 1 in 2pz. Now, the orbital that's going to bond in fluorine is going to be the half-fill orbital because it has space, it has room to accommodate another electron. The other orbitals cannot bond because they're already full, they're completely full, they cannot share electrons. Now, if I draw the shape of a fluorine atom, it's going to look like this. There would be a nucleus in the center. There would be an s orbital, a small 1s orbital that's going to have how many electrons? It's going to have 2 electrons. Then there's going to be a 2s orbital that's also going to have it's also going to have 2 electrons in this region. This is the 2s orbital. Then you're going to have the 2px, 2py, and 2pz. So let's say this over here is my x-axis, and this axis over here is my z-axis. This is the x-axis, and the y-axis is coming out of the page and going into the page. So the three orbitals 2px, 2py, and 2pz. This is going to be the 2px orbital. This over here is going to be the 2pz orbital, and this over here is going to be the 2py orbital. So just listen this. I've oriented it this way that the 2py orbital is actually coming out of the page. So the orbital which would be involved in bonding would be the 2pz orbital. This one, it's going to have just 1 electron, so it's got room to accommodate an electron. So let's redraw the fluorine atom. Let's redraw 2 fluorine atoms, and this time I'm only going to draw the orbital which is going to be bonding. So this is the nucleus of one fluorine, this is the nucleus of the other fluorine. I have one. So this is my 2pz orbital. It has just 1 electron in this entire region. So this is one fluorine. This here is another fluorine atom. So this is also 2pz. It has 1 electron in its region. Now this nucleus is going to attract the electron which is roaming around over here. So that electron is going to get attracted to that nucleus. Similarly, this nucleus over here is going to try and attract the electron roaming around in this region. What eventually happens is that the two lobes, they start to overlap. So they get attracted to each other's nucleuses, and the two lobes, they start to overlap. And this over here is the region where you're going to find 2 electrons. Now 1 electron is being shared by this orbital and the other electron is being shared by the other orbital. So these two are the fluorine nucleuses right in the center, and this here is the new bonding orbital. There would be an electrostatic force present. The positive nucleuses are going to be attracted by this electron cloud, which is now residing in the center of the two nucleuses. It's between the two nucleuses, and there would be an electrostatic force present, which is going to keep the two atoms sticking to this electron cloud.